Okay. Height is
If you can hide,
yeah. Go no, the
here,
height
hide
floating. Yeah.
Okay.
Went to mother-in-law's. في واحدة بس ما ينفس. Yes.
طيب السلام عليكم. Good afternoon everyone. Welcome to this second session, today's session titled Machine Learning Models for Predicting Student Performance by Dr. Hussein. Dr. Hussein Sama is a research engineer at KFUPM Joint Research Center for Artificial Intelligence. His research focuses on the machine learning, deep learning, reinforcement learning, and their applications. So without any further ado, welcome Dr. Hussein to this nice invitation.
All right, Bismillahirrahmanirrahim. Assalamu alaikum. Thanks, Simple, for your nice introduction. This is me, Dr. Hussein, as mentioned by Dr. I'm going to talk about building machine learning for predicting student performance.
So we move to the outlines of this presentation, as you can see here.
So basically, this kind of presentation will try to cover only three topics, because as you know, as a machine learning, all of us, or most of us are familiar. Now we are looking for the application side of this kind of machine learning. So we start with a kind of background about the link between the education and the AI in general, and then we move about because it's kind of hands-on, so we have some kind of diagram. So we'll explain in details how to build this model and how to use some different case studies. And the third part, of course, will be the practical. So before I give you the term to apply, the materials, I'll try to go through the code quickly. Of course, it's coding. Some of you are not from this kind of background, so I'll try to do quickly, and then I'll give you the term.
So,
generally speaking, this kind of problem of student performance prediction is related to the science of educational data mining. So basically, educational data mining is the research field that concerned about the application of different domain. As you can see, it combines data mining, machine learning, statistics in order to get some kind of insights and analytics from the educational data. So when we refer to the mining here, the concept of mining here is from the machine learning point of view, it is the use of the tools and technology or any kind of statistical design or whatever. At the end of the day, our target is to give the insights from a large repository. Sometimes you have the big data. So this is the aim of extracting the knowledge. So if we look at the main life cycle of educational data mining, the process, basically this process is kind of collecting the data, cleaning the data, analyzing the data, and inferring the data in order to get some kind of insights from these data. So the aim here is to improve, of course, at the end of the day, using these kind of tools in order to improve the education and learning process. So if you look here in this figure, we can see here on the left-hand side, we can see the producer of the content, the educational content, from where we get this kind of educational content. Basically, we have two main producers of this content. On the top, we have the online materials or the platforms that the students can engage with this kind of platforms in order to do some kind of educational tasks. At the same time, we have content that comes from the instructors of the lectures. So we have two kinds of producers here. And on the right side here, we can see we have also another kind of producers, but it is some kind of consumer that will interact with this kind of data, and he will produce what? He will produce the activities, the graphs, the physics, and so on. So after that, from this kind of interaction or combination, we get the educational data. So now the role of machine learning, it comes here, it will take this kind of framework, sometimes it's big data, and then we will do the analysis and pre-processing in order to get the insights from this data, and then we will come out with a new knowledge. So this kind of new knowledge could be in the sort of improving the curriculums, in the sort of creating some kind of personalized learning, and so on. So this life cycle will continue. This is a continuous process. We get the new data, we improve the model, we get new insights, and so on. So now if we look at this topic from the research point of view, this is not new topic, data mining in general, but if you look here, what the results shown here from the Web of Science, when we insert with PM education performance, student performance prediction, we can see that we have a lot of papers recently published, and we are expecting that this trend will continue in the next coming years. So now also, if we are interested in this kind of field, we have here some examples of well-known publishers, well-known journals that combine the machine learning with education. As you can see here, some examples in the table here. We have computer and education, we have IT interaction, and so on. So now, when it comes to student performance prediction, what kind of attributes that we are interested in? So we can see from this recent study that published in this year, they have highlighted different kind of attributes that can be useful for extracting the knowledge. So we can see here on the table, we have around 6 types or 6 categories of data that can be used in the during the prediction of the performance. You can see here academic performance. This is the most widely used in building machine learning models, you can see the frequency of using these kind of parameters. It is a lot. Then we have the demographic, the student information, the location, the title, the gender, and so on. And then we have the behavior. So this kind of behavior can be recognized as the number of raised hands, how many times the student visits the resources, discussion, attendance to the classes, answering questions, and so on. So this is under the category of behavior of the students. And finally, we have the psychological and family information as shown in the figure. All right, so now when it comes to the data, so machine learning without data is nothing. You need the data. Without data, you cannot build your model. So here we have some examples of publicly available data set that can be used to build machine learning models. Some of them are old and some of them somehow is recent. So here we see at the top, at the bottom here, in the red box, this is the data set that we are going to use in the hands part. So it's publicly available, you can download, you can get it. And you can see here we have around 16 attributes and the number of instances around 500 as can be seen. So the target of this task to build the machine learning model in order to predict the score here. So you can see we classify the score as low, medium, high, as can be shown. Sorry? Based on my knowledge, we don't have data. In the last rally, we have proposed a platform, one of the initiatives that presented the rally by our center to create this kind of platform. But based on my knowledge, I think we don't have this kind of thing. All right, so now we move to the technical part of machine learning. As you know, machine learning models can be classified basically into 3 types, as shown in the figure here. So this kind of classification is based on the availability of the data and the type of the data that you have. This will classify your model. So if we start with the first one, which is the most common, it is the supervised. In the case of the supervised, you should have the data and the label. So if you have the data and the label, so now you can try with supervised models in order to tackle your problem. But in the case, if you have unlabeled data, so in that case, you have to use different models, as you can see, clustering, dimensionality reduction, association analysis. So all these kinds of models could be used directly without using the label. So this is the key idea here. The third type of models you can see, we don't have the data. So we start collecting the data by interaction with the environment. It's used a lot in the case of robotics. So you will start by interacting, and from the experience, you will get the data, and the idea here is it's online training process. So for today, we will be focusing on the case of supervised learning. So supervised, we should have the data and the label should be come together for building the model. So in the upper part here, we have the data and we have the labels. So this is the part of building the model. So building model will happen here. We should bring the data with their labels, and the aim here is to find this function. It's some kind of approximation of for the input and linking to the output. After that, in the bottom part here, this is the inference. So now there is no need for the label because the model is already trained and we can use it. Yes,
Sir.
sorry, the label. You have a data for our case for performance prediction. You have some kind of students and you know priorly is it pass or fail, right? So we know this student will pass. I mean, it's offline data. You already have the prior knowledge. But you forgot the model.
Curve.
Now, for instance, in this semester, we will collect the data, the information about the students, and we wait until the end, and we will see who passed and who failed. So this is the label, right? Yeah. All right, so now for supervised classification model, which is the most common, we have two categories in this domain. We have the regression. In case your output is some kind of continuous value, so this will be a regression problem, and the task is to find the best curve that will fit the data with the least square error. So this is the regression problem. It's the same, the label, but the nature of the label will be continuous here. On the other hand, if your problem is just you have some kind of a few labels, for instance, here spam or not spam. So this is classification problem. So we see here, logistic regression is one of the oldest model which used in the regression and the classification, and we can see it's somehow the same algorithm, but here we just try to find some kind of probability based on the sigmoid function. So we are trying to match the label with the probability of inference here. We have another example here of supervised classification model, which is very old in the field of machine learning, but it's still effective if you are working with small data. So basically the idea, we have some kind of tree here. From the attributes, you can see here, the task in this figure, the task is to predict, is it low or high? The rest, the hard is it low or high? So it's binary problem. But in terms of features or attributes here, we are using three attributes, as you can see. The edge at the top, and we have the weight and whether is it smoker or not. So we have three attributes and we have one output here. We have here another type of machine learning algorithm supervised, and it's called the naive Bayes. So this algorithm were built or were the origin of this algorithm is related to the statistical theory. We have the Bayes theory here. So basically we need to calculate the probabilities. Once you have this kind of prior knowledge, you can make the inference. As you can see here in the table, to build this kind of model, we have one input, which is the weather. But this weather, we have three scenarios or three cases. Is it sunny or overcast or rainy? And then we have the output, which is the action, whether you are going to play or not. So it's kind of one-to-one, but to look at the theory behind this It's very simple, and it's some kind of calculation of the frequencies. From your data, you have to summarize in this table to find how many times it was sunny, and the label was yes. It's just basic calculation. Once you have this kind of frequencies, now you can compare this data as a probabilities. Sorry?
Some months are rainy,
Yeah, if you have more,
should be time bound.
continuous, you need,
Like probability will not work all around the year.
of course, we need another attributes here, just for simplicity, we say the idea of how this algorithm is working, is some kind of statistics based on probability, the prior knowledge. So this is the prior knowledge. You have also the evidence from the history.
For example, in Saudi Arabia, January, February, full rain.
Okay,
May, June, it never.
so how many states you suggest here? Yeah, it depends on the history. But here you can see, we will compare this kind of frequencies to kind of probabilities. Based on the number of observations, we just make the decision to find the probability. So this is the building of the model based on this algorithm. So for the inferencing now, we already know the prior knowledge, we have the prior knowledge here. We have the evidence. And now we want to make the inferencing. If we have X, what's the probability of this is conditional probability. If we have X, what's the probability of this class? If it's sunny, what's the probability? Yes. But this for one attribute only. If you have multi-attributes, what you need to do, we need to multiply all these kind of probabilities. Here we have another type of machine learning model. It's supported the machine. It was very popular in the 10 years ago or more. So the idea of this model, it's used or it benefits from the use of the kernel. The kernel that will transform the data. You can see in this example here, if your data, you have only one attribute, you have X1. If you got these instances here, you have two classes, the red one and the green one. So before using SVM, now we cannot find a linear hyperplane that will isolate the data. So what you need to do, you have to do the transformation of data in order to be linearly super. So this is the core idea of support with the machine. So this is another type of ensemble or combining multiple models together. Of course, this is one type of ensemble learning. We have the bagging, we have the posting, we have stacking. Here we have the bagging. We spread the data for multi-models. This will improve the variance, will improve the bias of the decisions, will combine the evidence from different things. All right, so now we move to the second part of this workshop, which is the pipeline, the main pipeline of machine learning models. If you want to use machine learning models, you have to go through all these steps here. So we can see from the left-hand side here, we can see first, we have to bring the data. All right, so this raw data, it is very noisy, something is missing, so it's raw data. After that, we have to do some kind of reprocessing here. So we have clean step in order for removal of noisy or finding the missing attributes and so on. After that, we have to convert all the data from the categorical format to be in numerical format. Of course, we need some kind of scaling here to be within the range of sometimes from 0 to 1, it depends. So after that, once we finish the pre-processing steps, now we can pick up one of the models. Of course, you can combine, but we assume here you would use one of them. You have to train the model after you split your data for training and testing, and then once the building finished, then we have the evaluation step. So now, in terms of data format, here in the scope of this session, we will be focusing only on the kind of temporal data. So we do have the audio, we do have the video as input, but of course, you can use it. But at the level of this workshop, we assume that our data will come to the as a structure format to be homosegregated or XML or any kind of structured data. So this is the format of the data. And then you have to apply the cleaning process. Cleaning means that if you have missing data, missing attributes, if you don't have information about whether he's male or female, right? So you need to take sometimes the mean of the data to replace the missing data. If you have noise, you have outliers in your data, it's better for you to get better accuracy. Of course, sometimes you have a big data, you have a huge number of features. So it's recommended sometimes you have to do some kind of feature selection. At the same time, maybe you have a big data. So your model cannot know the whole data better. So you can do some kind of sampling. So after you clean the data is ready. We need to do another step, which is the encoding, because here, as a computer, it will work only with the numbers. You can't work with characters. You have to do the encoding step. As you can see here, you have two types of encoding. The first one is just to give a label for each attribute. You just give a label from 0 to up to the size of up to the number of observations here. Another type of encoding here, which is the one-hot encoding, you have to give for each attribute a value, whether it is 0 or 1. After the encoding step, we have to do the normalization of the data. Of course, these kind of steps should be automatic. The programming tool will do it for you, but here we try to understand what's going on behind the scene. So we have two kind of normalization because sometimes we forget about this step, and our budget is poor. It will get to not good results. That means you have to do the normalization step. So as you can see, you have two types. The first one is just converting the whole data to be in the range of 0 and 1. It's just the division between the interval here. And the second one is based on the main and the fairness of the data. So now we come to the evaluation measures. Sure. Feature selection. Sorry? It depends. Sometimes you need to try. It's some kind of design. So based on the data. Most popular is from 0 to 1, but also it should give you some kind of graphs and distributions, and variances you want. So sometimes you need to try. Okay, so now we have the evaluation measure. This is the confusion matrix, which is very popular in evaluating the machine learning models. Here, what you see in this table here, we assume our problem is binary, whether it is spam or not. We have more multi-classes, so we have bigger confusion matrix. So what we can see here, we have two different types of errors. The first one is type 1, which is less expensive, you can call it. It's the case of the false alarm. If you have an email and you label this email as spam, but really it's not spam, so this is a false alarm. But the case of type 2 error, which is more expensive here, if you have a real spam and you miss it, so this is more expensive here. In that case, if you build this kind of models, sometimes you have to give weights for this kind of error to reflect during the training process. So now we will move to a real case study. It is a research paper that has been published last year in the field of education and information technology. As you can see from the title here, the aim of this paper is to use machine learning models for predicting the academic performance of the student. So if you go through this paper, you will see the data set, the models, and the results. So first, the data. What kind of data that I'm using here? You can see we have around 32 attributes. The target of this task is to predict the G3, so the final grade. Okay, so this is the label. All right, you will exclude this label from the data because this is our target, and then we have the rest of the data. As you can see, if you go through quickly of this data, it's around 32 attributes. So basically, as mentioned earlier, we have the demographic information, background about the family, maybe the time to reach the score here, the quality of family relationship, and we have, as you can see here, some of them are binary, and some of them has a range. Okay, so now we will move. I will go quickly because I just a few kind of future, but the idea here, once we have the data, we have to go through the pre-processing steps, cleaning, normalization, and then we need to split the data. Because in machine learning, we have only one data. That's why we need to split portion of the data. Usually we are using 30% of the data will be hidden for the model until the end. Once you have the model, you can see that sometimes you use cross validation, problem splitting, and so on. So now we can see from the pipeline here, they are proposing different kind of models. You have the gradient post, you have the light version. They have used three kind of models. But before that, during the training process, they have some kind of parameters to it. You have to find the best set of parameters for each model. Once you have it here, the best set, now we have three models to be created, as you can see here. And then we will combine the final decision from the three models, and we have another model, which is the meta classifier. So the meta classifier will use the output of the previous state. All right. So the meta classifier basically is the best of these three. Just pick up the best and use it again, as a meter classifier. But the input here, as you can see, you have only one input.
Okay, so you move to the results here. We can see before we train the model, we can do correlations, the statistical analysis of the data. So this is our target here, G3. G3 is the target. So we can see here, we have a correlation, we have a high correlation between G3 with G2 and G1. Because that makes sense. It's some kind of initial results of the student, the marks, the initial marks in G1 and G2. Also here, we can see some attributes. There is no correlation with 0, and some of them will be negative. So it's the opposite of the prediction of the model. All right, so here, when they conduct this kind of analysis, they do it twice. In the first analysis, they make this kind of problem as a binary, whether the student will pass or fail in the course. So they change the score. If above 10, it will pass from 0 to 20. If above 10, they will consider it pass. If less than, they will consider it fail. We can see here some of the results of different models. There are 3 baseline models. Of course, I need to mention here the task of the prediction here. They have 2 kind of data. We have data for the math, for the class of math, and data for the class of voltages here. So we have 2 different data. We can see here from the results here, because it is machine learning, sometimes we give you better results in some cases, and we give you the opposite in other cases. If you look at C, we can see here, it is in the first model, will give you the best, but in the second model here, we can see A is output for it depends on your calculation. You have to find the F-score and other measures. So now, in the second part of the analysis, of their analysis, they consider the mark of the students will be categorized into 5 types here. From 0 to 5 will be 1 from, so as you can see here, we have a bigger confusion matrix. This one for the math, and this one for the voltages. So at the diagonal line, when you do the analysis of the accuracy, you are tested here. If this one goes up, your model will be better. So here we have some results also for the meta classifier when you combine with the vector 2-stage. All right, we have another case study here. But now, the most interesting part in this study, we want to get some kind of analysis, more analysis or insights using the concept of explainable AI. So instead of taking the model as a black box, we will do another analysis to understand, to find the impact of these kind of parameters in the model. So we have the concept of explainable AI. This is the recent paper here, as you can see, and the target here is to predict whether the student will drop the course or not. This binary classification function. We can see here from the data, we have bigger data. We have 157 attributes, and the target, as we have mentioned, the target is to find, is to predict the student, whether the student will pass or fail. Of course, we have different attributes, as you can see here. We have information for the education, the score, the grade, the score.
student information, extra class, financial situation, birth information, location, statistics, the current grades, the cumulative grades, and so on. So now in their analysis, they have used around 6 models or 5 models, as you can see. Some of them are basic, like the decision tree and the district regression. Some of them are advanced, like the random forest. These are the attributes of these models. So now when it comes to explainable AI, the explainable AI part, what they are doing here, they are using the tool. After they build the model, this is the black box, as you can see here. They don't have any information what's going on inside the model, how the model makes the prediction, which attribute influence more in the prediction. So they have used this Shapley additive, which is a tool. So once you have the model, you just pass your model to this tool in order to get some kind of explainability. So we can see here from this example is not related to the paper, just for illustration here. You can see the edge will influence more, make more impact, meaning that at the top, this is the most influential variable or attribute on the decision. If you go down, this one is the least influencing parameter. Sorry, yes.
Is there any difference between the red?
Yeah, we will explain it. Explainable AI. It's related to the game theory. You have a game, and you try to play around the parameters and see the influence on the output. You keep tracing others and changing the input. It's changing the input, and you will see the effect.
Is it supervised or?
Unsupervised. It's a tool.
Oh.
It's a tool. Once your model is trained, just do the analysis. Explainability. All right, so we can see here from the results using explainable AI in the figure here, figure 4. So the most impact you can see on the x-axis here. This is the impact on the model. If you change these parameters, you will see that there is impact or not. So this will measure how much the variation on the decision of the model. On the y-axis here, we have the attributes, but these attributes are sorted from the top to the bottom. So at the top, this will be the most important attribute. All right? So we have different data, as you can see. Some data for preschool, some data for basic education, some data for secondary education. You can see here, this one for the basic education. The most important attribute was the marks in the physics. So now, to explain this figure, we can see when we increase the value of the function or the attribute. So when the attribute is increased, when it becomes red, there is no effect. But low value will affect more, right? So this is analysis. If we have low mark in physics, it's more expected to withdraw. That makes sense. All right, so it's sorted from the top to bottom. All right, so this is the last slide here to summarize what we covered in this session. So even though we have the machine learning, but we still are facing many challenges. The first one is the rating of the data. If you don't have the data, and good data, of course, should be, otherwise you'll not get the benefits from machine learning process. We have another technical problem, which is related to of a fitting and other fitting related to the model. Sometimes the model will perform well in the training, but in the testing, it will not work. The last one is related to the fairness. Sometimes you are biased, the data is biased. You are making good projection for some group of people, students. So it's the bias that we see them. This is the end for the theoretical part. Now, before you scan here, we have another interactive material, but let me show you before you try from your side about this hands-on. Sorry, I will reshare. I will reshare. Just now, I will show you. We have only one activity here. So basically, what we have here, we have two things. The first one is the data that I will share with you, which is public data, as we highlighted in the previous slide. We are using 16 attributes. And here we have the code. This is code app. You just need just to have an Google account and run this code. So what you need to do once you download the material, because it's compressed, you get some kind of compressed data, you need to extract these files and then you move to the collab. As you know, this is the link here. You have to open the link here of collab research, and then you have to upload the data. Okay, so sorry. Okay, I will go through and I will give you that if you wish. I'll show first. Let me show you first. Quickly. All right, so I will explain the steps, because once you get the code, you don't know what's the required steps. You will get these files, and then you need to open the code up. You have to upload the data. You have to find the link of uploading, and then you just drag and drop here. Upload the code here.
Because I'm online.
You mean what? I share the materials.
In the link.
The collab. It is collab research program. The material you do. Yes, let me explain first.
Like it.
Yeah, but in my case, you have to bring the data. The data is online in this case. But my data is offline, right inside the collab. So now this is not the end, this is the code only. We need the data also. So what you are going to do here is to open this tab here and drag and drop the data. Okay? That's why I cannot give you the link with the data. I can give you the code, but you need this specifically. So this is the reason. All right, so now if we go through this code quickly, we can see first. Sorry. Okay, I can share now. You can follow the steps. Let me maximize. So you will get the materials only. You'll get the zip file. So you need laptop. I think you can't use the mobile.
If you share a full.
Yeah, send us the link. Don't end black box.
much motivated. Can scan for like
You will get the zip file. You will get the zip file. This link will give you the zip file. Oh, you mean the link? The link is how to put the link here. Okay, I think I have the link here.
Yeah.
But again, how you can get this link here? This is the link. Again, the same issue. You need just to send to your laptop via WhatsApp or whatever. Okay, so now what you need to do once you load the code, you need to run the whole code. Okay, you need to run all the code. So now we can see we have 16 attributes as mentioned. So we have different attributes here. Sure, sure. You have to open collab research once you have the data and then make drag and drop for the code and the data. Education. The code review and compress first. Yeah, we have code and data. You have to uncompress first and yeah.
لا لا لا
Yeah, I should have to get it. Okay, yeah. Yeah, okay. No. No. Yes. Okay. And then going from here, and then you have a turn off. So you want that. Yeah, I'm here to find. Yeah. Yeah, you will get there. Right, right. Yeah, there is no. I know.
Outside, outside.
Inside the field.
You don't have this. Sample.
And just make sure that all the cells.
Yeah, I get.
It's okay now. I can take a little front horse.
It has outside, right?
The code will upload the data. Once you open the code first, you have to start it. You continue to start it.
Yeah, not start the
Not inside, not inside.
outside.
It's going to be outside.
Let's see.
But you will get the error if the data is not there. So it's upload again. From here, you just click on. Now run call. It's okay for you? Yes. So at the end, you will see the experience later.
Yeah.
Next, with the report about the results first and all right, so you can see here in this exercise, we have 5 models. We have TNN, we have the artificial neural networks, we have the regressor, and it's a total of 5 models. So the idea here is to give you the concept that some models will work well and others will not work, and to do the analysis of the explainable AI. If you can see here, from the results point of view, we can see. So we move up. All right, so now this part, the last part of this code will be related to explainable AI. After you build the machine, you can apply the explainable AI. It's the last part. But before that, we have the models here. We have 5 models. You can see the first one. The first one is the logistic regression, and the outcomes of this model in terms of accuracy, it is 78. Okay, so this is the first results you will get from the first model. So there is no parameters here. We assume that we take the default parameters for this model. But if we go down, this is the, by the way, we have a total of 480 instances and 16 attributes, and we here keep all the attributes. Sometimes you can see, just as a human, you can see some of the attributes are irrelevant, right? Like the ID or something. It's unique for the user. You can
do the grading process. But here, we keep all of them in order to see how this relevant AI will work. All right, so we have 16. This is the raw data. After that, we have to do the encoding here. As you can see, this is our data. We just display. We just display here. After you load, your data should be visible here. Make sure that it's visible. You will just load the first 5 instances, as you can see here. Right? So after plotting, so this is shape, yes. As you can study here, as you can see, for student, but as a machine learning in general, you can, if you have any data, based on your measure, you are working materials, some features, these materials, you can do the predict. This is general. At the university level, if we have the platform, we have the data and we have the platform to do to give the insights, the analytics, as explained the first slide. It should be, of course, at the university level. If you can access the data, you can keep monitoring the history and you can make a decision, of course. At the end of the day, educational data mining, the same, to get the insights, to improve the curriculums. Right? This is on the upper case. But here in the upper case, it's a machine learning in your hand. You can use it for other tasks. It's not specific for education, but this is the same concept. We have a tabular data, so we have to go through all these steps. Okay. So now this is the data. We have 16 attributes. Before we do the encoding, you can see it is in a technical format. So we in total we have 16 attributes, but also we have the label. So the label here, it will be, as you can see here, where is the label? Okay. It is classification, but we can see here, you see, this is the 3 levels. Whether the score is low, medium, high. This is the level. The last column, yeah, right. But this is the information about the level. Okay, so this is the last column here. Low, medium, high. And after loading, we have to go through. This is shape. You have to find how many unique attributes in your data here. And then you have to check if you have missing data. So this is the function is null, not being empty. Then encoding, you have to do the encoding. After that, after the encoding, you have the normalization. Once you convert the data to be a numeric format, you have to do the normalization. And then we are using minimax, meaning that the values should be from 0 to 1. After the normalization of the data, should be in the range of 0 to 1. So for the analysis, before you use your model, you can get some insights about the data, the correlation. So this is the correlation. You can present in different format as a triangle here. This is another option to change the view. And you can see at the bottom here, we are interested in the class, in the label here, this label. The class is the mark, to present the mark of the student. As you can see, we have some high correlation with the absence days. If the absence days is going up, that means the mark will be low. It's negative. And also we can see here, we have a correlation with the resources, the physical resources, how many times you visit the resources.
So now in terms of correlation ranking, the attributes we can see from the correlation point of view.
The physical resources is the correlation of the class with class, so it's one, because it's the same attribute. But with the physical resources, we can see this attribute is important from the statistical point of view. There is a high correlation between the output and the input. Without, we see likely is irrelevant to the decision.
And after that, after we do the analysis, we have the models here, okay? We have the models. We have to prepare the data.
We need to split randomly. This is 70-30. And then we have to take the training. We will feed the training data for training the model here. And the testing will be hidden. And after that,
We have the first results from the first model, which is 78. Okay, we have three classes,
low, medium, high. If you look at the diagonal line, you're interested in the diagonal line. So you can see for the second one, it's performing worse. That is, it's confused the model between the high and the low. Sorry, this is the precision reproductive optical matrix. This is the precision and control. And then we have
the confusion matrix here. See how many instances?
were classified correctly. Of course, here on the test, we have to keep 30% for testing, so we can see from the results here. We have for the high, that means how many instances were low and classified as high is 0, but we are interested in that line.
As a normalized values, we can see that as a percentage of accuracy. Based on the total number of
Instances, we have 95 for the low class.
we have another classifier, which is the decision tree. We can see from the results it's worse, 66. We have another one, the naive Bayes, 71. And multi-layer perceptron. Of course, you can play around the parameters here to increase the number of failing neurons and so on for tuning these parameters. Then we have the results of 73. So if you want to try this one to change the number of neurons to be 100, okay, you just change and run again. So it's simple.
Could have just run the code direct. Okay, we have increased the number of neurons in the hidden layer.
All right, so the final model is Canaan. It will give you 70%. And for explainable AI, we can see that the student absence days is the most important attribute here. From the data, this is the most influential attribute on the prediction. Sorry? The gender, the importance of, yeah, for the gender here, the blue value is meaning it's 0 and 1. If 0 means that you see the changing, it's not like this, but means that the variation of the value, because we normalize the data from 0 to 1, so it's some kind of routines. That much. The top, see the range of variations here. The top will affect more. Okay? Yes.
Yeah, let's take the first one, student absence days. How do you read the blue and red? What is that? Like, what does it mean?
The value of the feature of more absence. Okay? So based on the range here, the range of the value. If 0 to below, this data will be transformed to 0 to 1 because you have the normalization, right? You have 0 to 1, and this one will scale it again to be the less than 0.5 will be negative and more than 0.5 will be cannot link to the original value, but this is the finding here. Yes. The small dots here. It is here. What's going on here? You mean this one, this alone here? The blue? Not the student, the attribute, the value of the attribute. The value, yeah, changing from low to high. That's specific students. Now you have a range. How many absence days the maximum? In your data, the maximum maybe 10. So you will change from 0 to 10, and you will see the effect. So we can see here, when we have different models, this is for naive Bayes. So all of them agree about the student absence days was considered as the most important attribute here. All the models agree about this. The second one is the visited, how many times the students have visited the resources, it's the same. But for this model is different. For the MLB, it is the relation. So sometimes your model will be wrong. You will understand from these kind of insights if the model is working correctly.
It's computational expensive, isn't it?
Yeah, but not like this. I think it's running with CPU here because in the cloud, if you show continue run it in your machine, it will be faster. Second, because you will try all the scenarios. For some models, it's faster. For KNN, because KNN you need to find the nearest neighbor.
each time we change the value, so it gets different time.
And for you, consider like you are an expert in prediction models. Which one is your favorite model? Which one do you think is like not computational expensive, not cheap, good fit, not bad, like a perfect balance, perfect model? For you,
You mean balance in terms of computational and accuracy, right?
like a good balance model from everything, like which one is your favorite?
If I go through these models for the logistic regression, because you have to understand the theory behind it, how it's calculated.
Yeah.
So decision tree will be the easiest one because the inference is faster. But for neural network, of course, and the key nearest neighbor, it's about the inferencing, how the nature of the inferencing. Now, for KNN, you have for each instance, you have to define the data. But in neural network, you just feed the input and you get the output. So the neural network is the most popular, but the problem, you have to design how many layers you have.
And it's very dark, the way it's designed. It's not like a theoretical basis.
No rule of thumb. So this will be better on trial and error. Yes.
How do you think, how we can improve the accuracy score for this model?
The accuracy. If you look at the paper, what they did some kind of tuning the parameters. You see here, if we back to the slide, for improving the results in the first one, you see here, there is some kind of finding with this the optimal parameters. So if you conduct this step, if you can do it, this will improve. Also, sometimes feature selection, you have a noise in your data. So you need to find something with feature selection. This is important. Okay, so you have to take care about the built-in parameters of the model. What's the best architecture, how many layers to solve, and at the same time, the data. If all done, maybe we can end this session. If no more questions. Yes. Sorry. Yeah, here what we have here, we have the attributes. And this is the value of the attributes. We change the value of attributes from low to high based on the range. Okay, so you will increase and you will see that on the model. If there is change in the decision of the model is predicting something. And now you will keep all the parameters fixed, and this is one of them. If you look at the black box, you have some base value, you have to change it. So now you will change it, and you will see if the output is changing or not. If it's changing, that means this is influencing one. Yes. Glasses.
Yeah, for the يعني the blue is like a glass and the red is another glass.
Value. No, it's value. The horizontal, yeah. This one may back.
You mean the binary classification of the right or the left number and still class and the second one is
That was it's influencing if changing the decision. Now this is my model, and I will feed the initial data. We see the output. If I change the one parameter, this is the absence date, how many absence date. If I change it, make it more. Does this will affect in the right or the left? That means the prediction is low or high. At the end of the day, there is a variation. Okay. Yeah. It's more influencing. When the value is high, the absence A is high, the failure low. You will get a low mark. Yeah, the low mark and maybe medium. But for this one, the influence is less. Will not change the output. Yeah.
Thank you so much. I guess I think we can do that. Maybe just one comment to add regarding maybe the question. How can we benefit from this as an question? But I think exploring the area by something what can AI do? What's possible? What's not possible? This is, I think, the idea behind the technical things, and maybe we can have more training on that. Maybe we need more technical sessions, but at least we have a general, let's say, general picture about what can be done to AI, to machine learning, to this kind of different algorithms, and what is possible, what's not possible. Okay.
Regarding some doctors are familiar with Python. So there are a lot of tools used as user interface to apply this task. So they can
Some tools will just you need to feed it with the data and to set some parameters, just the mouse actually, and that's it. So there are tools which you have to do some kind of coding, but again, this is the idea of it, which what can AI do for us at the university. Thank you so much.
Thank you so much for this. Thank you. Yes,